A temperature transmitter is a device used to measure temperature accurately and transmit this information to a control system or monitoring equipment. Let's delve into how it works. Temperature sensing element. The core of a temperature transmitter is its sensing element, which directly measures the temperature of the medium it's in contact with. There are several types of temperature sensing elements, but the most common ones are resistance temperature detectors (RTDs) and thermocouples. RTDs are made of materials whose resistance changes predictably with temperature. Typically, they use a platinum wire wound around a ceramic or glass core. As the temperature changes, the resistance of the platinum wire changes in a known and repeatable manner. Thermocouples consist of two different metal wires joined together at one end. When the junction of the two metals is heated or cooled, it produces a voltage that is proportional to the temperature difference between the junction and the reference point, usually the other end of the wires. Signal conditioning. The raw signal from the temperature sensing element is often very weak and susceptible to noise and interference. Signal conditioning is the process of amplifying and filtering this signal to make it robust and accurate. This typically involves amplifying the signal to a usable level and filtering out any unwanted noise. Linearization. The output from temperature sensing elements may not be linear with respect to temperature, especially for thermocouples. Linearization is the process of converting this nonlinear output into a linear signal that directly corresponds to the temperature being measured. This is often achieved using linearization algorithms programmed into the transmitter. Cold junction compensation for thermocouples. In the case of thermocouples, the transmitter needs to compensate for the temperature at the reference junction known as the cold junction. This compensation ensures accurate temperature measurement by factoring in the temperature at the cold junction. Output signal. Once the temperature signal is conditioned and linearized, the transmitter produces an output signal that represents the measured temperature. Common output signals include analog output. The transmitter generates a continuous analog signal, usually in the range of 4 to 20 milliamperes, where 4 milliamperes represents the lowest temperature and 20 milliamperes represents the highest temperature. Digital output. Some transmitters can communicate digitally using protocols such as HART or Fieldbus. These digital protocols provide more information and diagnostic capabilities compared to analog signals. Power supply. The transmitter requires power to operate. This power can be supplied from various sources such as loop power, external power supply, or through the communication loop itself. Calibration and configuration. Before being put into service, the transmitter needs to be calibrated and configured. Calibration involves adjusting the transmitter to ensure accurate temperature measurement based on known reference temperatures. Configuration involves setting various parameters such as measurement, range, output, scale, and communication settings according to the specific requirements of the application. Mounting and installation. The transmitter is typically mounted near the temperature sensing element in a location that is representative of the temperature being measured. Proper installation, including considerations for factors such as vibration, electrical interference, and environmental conditions, is essential for reliable operation. Overall, a temperature transmitter works by accurately sensing the temperature using a sensing element, conditioning and processing the sensor signal, and transmitting the temperature measurement to the control system or monitoring equipment, all while ensuring accuracy, reliability, and compatibility with industrial standards and protocols. If you want to know more about temperature transmitters and how they work, please visit our website